Okay, a little bit of a review. I'm going to finish out week 2, the basics, and the previous video we covered. I'm thinking you're seeing my module again. We covered, excuse me, basic state marking, and then we covered uh, the terms. We covered a little intro where it had the guy that got trapped in the scraper story. Talked a little about safety. Excuse me. Talked about the hand level and how to use it. And we talked about transferring grade from a known grade to an unknown and establishing a new grade there. And the where we left off, we had I want to take a look and see if there's a couple of things maybe that I could go through again. Let's see, I'm going to start here. I think this is still in the intro, but we got into the meat and potatoes, as I said here, uh, just identifying cut states and talking about the crow's foot as being the reference from the point when you're cutting. You will be using this crow's foot or a hub, whichever the surveyor sets, or if you're out there setting one, you'll probably just use the crow's foot. But the hub serves the same purpose. It's a 2x2 stake about 6 inches long, driven in the ground, and it is your reference point. This one right here is needing this place right here. Couldn't get the word out. Where this stake is at this point, it needs to be, the grade needs to be along this line. Now, just consider this. Let's say that you had a road or something, and your existing grade, and you wanted to cut it down to here, all along here, and you'd have several stakes telling you how to get from the existing grade down to the proposed grade, the final grade. Well, not necessarily finished grade, but where you want it to be. And we talked about in this particular case, why is the cut more here than there? Well, it's because the stake here is initially higher above the proposed grade than the stake is here. In other words, the existing ground is closer to the desired grade here than it is here. So the cut has to be more here. But the plan would be to get a level cut at this elevation. And I think we went through elevations. Those were points above sea level. And I told you that the National Oceanic Atmospheric Administration, among its agencies, there's a USGS, the U.S. Geological Survey, and they have permanent benchmarks throughout the country, and so do other countries have them, so that we can find out how far above sea level is, and through differential leveling, we can go to our site and transfer that elevation, and differential leveling is something that we'll get to later. So there's your cuts, and that's why this is different from that one. In this case, it's a fill, and again, you can see that we are a little bit lower here, so our fill is going to be a little bit more to get to this proposed grade. Over here, the same. In this case, this hub is on grade, and so is this crow's foot on grade, because it says so right here. GR stands for grade, GRD stands for grade. So these two are basically level. We're going to have to come in and fill a little bit right here, and come in and fill maybe, it depends on you know, what our tolerance is. Our tolerance a tenth, or is it in hundredths? Do we have to be exact? And then we may need to overfill because we'll be compacted later. But all that stuff will come later. And here we just talked about marking vertically on the stake and making sure we're clear. We brought up again the little horizontal line below the 0 indicates that this is 5 feet and 1/10 of a foot. It's 5 foot even. I'm looking at the 1. It's 5 foot even because that's a 0, no tenths, 5 foot even. Here it is again, 5 foot. Now this little sign we will see again in both this course, and if you're in excavation, intro to excavation, that course also. So this is telling you you want to cut 5 foot at something. Maybe you want to cut 5 foot at 10 feet. Well, that would indicate a slope out here that goes down 5 foot. Or it may be an offset like we talked about, where this cut needs to be done out here. I want to say there's not many things out there that are level other than a building pad. Like you're going to put a pad to build a McDonald's or a house or something like that. That's going to be level. But your roads and many things, your back slopes, in slopes, all those kinds of things are designed for drainage to keep the water off the road, to keep the water running, not down the road, but over into the ditch. So we're going to keep moving. And remember, you've got a canvas inbox where you can say, man, I got lost on your, when you got kind of lost on, just maybe I couldn't come up with a clear answer and you want me to clarify something, use that inbox. It takes it just a minute, just because we're 200-300 miles or more apart doesn't mean we can't communicate almost instantaneously. So let's take advantage of that. The one we just left is the one that here's the engineer scale again. It's really hard to read, and I hope you took some time to watch this little video right here, because it does provide some clarity. And this, remember, if you want to convert inches to feet, you divide by 12. If you want to convert feet to inches, you multiply by 12. It's simple as that. And this is what that's going to. It's taken 5.5 inches, dividing it by 12, and it's coming up with 0.463 feet. What I think they came up with maybe 9/16. No, that would be, well, I'm going to divide it. I think I can find my calculator. So 5.56, that's inches. 5.56 divided by 1, 2, 12. That would be 4.463 feet. Now, if I take that, multiply it times 12, I get 5.56 feet. So that's your conversion factor, 12, either way you go. So this will come as we move through the course. If it's a little confusing, again, if we need to set up a one-on-one, or you guys as a group, 2 or 3 of you want to set up a Zoom through Canvas, the big blue button, we can also do that. And I probably would like to do that before we leave this week, if we can get enough folks together. We have quite a few people in the grades class. So moving right along. We went through vertical measurements, and again, just briefly, you can see that here's a known, we don't know what the elevation is, nor do we care right now as a grade checker. What we need to do is put a stake here. We need another stake to see what we have to do here. Right here, we don't have to do anything because according to this GR, we're on grade here. So we want to get on grade over here. And the last video I said, if he takes a shot and he reads 3.0 feet on his engineer rule, that means he's 3.0 feet above the existing grade. So he needs a fill of 3 feet. That's all there is to that. So he could put this mark, even since it is grade, right here, but he would still need to tell you what to fill, how much to fill from the existing grade. And in this case, it'd be filled 3 feet. So you would bring in dirt till you got up to this level right here. It's also his line of sight, but this is also grade in this case. And it talks about getting comfortable to use a hand level. I hope, when we have our in-person, we usually combine, or I would, the intro to excavation, intro to grades at the same time, because they both cover site plans and contour lines and all the same thing. So we usually do that and get it knocked out together and work on these things, actually applying this stuff with the hand level. So here it's, this is a case where I would say, okay, what goes on the stake? And then right now, as I pause, you probably are thinking, well, I don't know what you're thinking, but you need to look at what you know. You know that from this cut 2.8, you know that this crow's foot is 2.8 feet above the proposed grade. So when you take a shot here and you mark it here, they're telling you actually what you're reading right now, because you would look at your ruler and you would look at your hand level and you would see that it's reading 1.7 in this case. Well, you could draw your line there, and then check your measurement, and from that line measure down and say you got 1.7. So you got that verified. So what's going to go on this stake? Now, this mark that we put on the stake using the hand level is level with this mark. So we know that from here down is what? 2.8, because that's what we want. So that's what we've got to have here. We've got to read, when we get down here, right, and we take a shot at this thing, we need to be reading 2.8. So we're down 1.7, so we need to go down a little bit more so that we'll be down 2.8 feet below this reference point here, which is on grade. So just take the 2.8 here minus what you have here, and that's 1.1. And so you need to go 1 1/10 deeper. So what do you put on this stake? Cut 1 1/10. And that would be from this point here down. Now, in this case, I'm going to jump ahead just a little to show you what we're headed for. What if once we got this cut out with a dozer or whatever, down to where we thought it was right, how could we verify that? Could we not? This is gone. All this is gone. This existing ground. We got ground. Our existing ground now is the proposed grade. It's down here. Could we not stand up and stand here and put our ruler right here and take a shot at this. And what if that shot read 2.8? Then we would know we were on grade. But what if it read like 3 foot? Well, we just haven't gone down enough. I mean, we have gone down too far. If we were reading here, standing down here, reading on our engineer scale, if we were reading 3 foot, we would be too low. I know that sounds backwards. The higher your number, the lower your depth. So what we want when we're on grade is for our reading with our engineer's our engineer's rule sitting right here on this, whatever the ground is right here. When it reads, sitting here, taking a shot at this crow's foot, when it reads 2.8, we're on grade. But if it reads 3 foot, we're too low. We're 2/10 low. So then, right here, we would need to fill 2/10. See, when we came in through here and cut, we cut it too low. So we'd have to put a little bit of dirt back in there and compact it. If you get that, you're well on your way to understanding a grade boot, which is coming up. Same thing would hold true here. When the same process is going on, and let me repeat it real quick since we're here. Cut 2.6, that we know. It hasn't been cut out yet, but we know that our proposed grade is 2.6 feet below this. So we're back over here on the existing ground. We take a shot, and according to the people that put this book together, we're reading 1.7 on the scale, and that's where we are. We're not low enough, because we need to be how far down from here? 2.6. So take 1.7 from 2.6 and you get 0 and 9/10 feet. So we would have to cut 0 and 9/10, 0.9 would go on this stake. Now, to check it once again, we could, after we came through here and cut this out, made a cut through here, we could come stand up, leave the stake where it is for now, and just cut around it. But we say, let me check it. So I get up and I'm standing down here now. You've made a cut with the dozer. I'm going to check. Have my engineer's rule from 0 to 6 foot, but it's sitting here now. This is all gone. When we have a stake that we want to salvage, we will cut around it and leave what's called a mushroom, just a little piece of dirt right there with that stake still in it, because we need to keep everything that we've accomplished so far. So this stake would say cut 9/10. So we need to leave it there. So we'll know that. So we cut around it, and so I'm going to jump down here. I'm going to bring my engineer's rule. I'm going to bring my hand level, and I can probably stand up now. And I'm going to take a shot over here, and I see that my shot reads, let's see, when it's on grade, it's going to read 2.6. But let's say it reads, let's say 2, right? What does that tell us? If we're down here and we take a shot at that and it reads 2, then we're too high. We need to cut 6/10 more down. Do you get that? Because we need to read 2.6 when we're down here shooting at that crow's foot. But we're reading 2.0. So if I drop the dirt down, if I say, come down here and make another cut, see if you can just cut out about a 1/2 foot. You kind of go by eye and let me check again. So I drop down there and I check it, and voila, guess what? You got lucky. you cut out exactly what we needed. I'm reading 2.6. A while ago we were reading 2.0. That's too high. But once we lowered it, we got down to 2.6. You know, it depends on your tolerance. That may be good enough, you know, because we're uh, maybe we got, if we were at 2, we're 6/10. That's probably going to have to come out. Now once we get it down to reading, if we were reading 2, we're going to have to bring it down in the 6/10 because that's too high. We have to read close to 2 6/10 for that to be good, especially if we're finished grading down there. Okay, things are similar here. We're just going in 2 different directions. Now we have a fill. So what do we know? We know from looking at this that we need to be 1.5 feet, 1.5 feet higher than this. We take a shot and we're 1.7, right? At this line, we transfer and put the line over here. So we're 1.7. We need to come up another 1.5 from here. So we've got to take where we are is 1.7 high. But honestly, to get that other from here on up, we got to add another 1.5 feet. And that brings us to 3.2. So on this stake, you would say fill 3.2. The reason the fill is higher is why? Because the existing grade is 1.7 feet lower than this existing grade. So now, when we put 3.2 on here, that's what the operator will know. He's going to have to bring dirt in here. And guess what? We can start taking shots as he's putting dirt in here, and we'll keep shooting at this. And when we're reading 3.2, we know we'll be on grade. We can't keep shooting at this. This is when the grade boot's going to come in. We want to be, what we want to do is be, when we, I'm sorry, this is the line of sight. This is the proposed grade. So we need to be 3.2 higher, right? So if I stood up here and I took a shot, let's say, how can I explain this? This is when I would put a grade boot in, because I need to come up higher here. We know I'm way low here, right? Because I'm shooting 1.7. So if I measured up from here 1.5 feet, then made a mark, that's where the new grade is supposed to be. So I know the new grade has to be 3 2/10 because that's how far up. So when I take a shot at that mark I made, by the way, that's going to be the hike up. I'm measuring up 1.5 feet, and that's where the new grade's going to be because it's telling me right there. I stand over here and I take a shot at that. When I read 3.2, I'm on grade. Does that make sense? My mark is on grade over here when I read 3.2. And so we can put a grade over here, pointing like you can see. That's 3.2 higher than this. We can put a grade mark right there. Now that's similar to what we're about to get into. It's just like, how do I do something that's not there? How do I create? It's just such an interesting story how this hand level thing came about. Used to, every time you needed to do this, you'd have to call a surveyor out. But you don't need a surveyor now that we know how to manipulate these numbers, or we're learning. Let's see what's next. the grade boot and the high cup. Okay, many times it's necessary to employ the use of a high cup. Now this right here, before we go any further, is the high cup, right? This is the grade boot. So many times it is necessary to employ the use of a high cup, and the high cup is used to set your grade boot. So you can read the engineer's rule more comfortably when grade is close to the ground, or when your view is obstructed. When your view is obstructed, as illustrated in Figure 23. In this situation, you would hike up 2 feet in this illustration. The mark on your left by 2 feet to a newly established target. All we're doing is we can't see it because it's a big mound of dirt in the way. We can't get a shot at this, so we're measuring up 2 feet to a newly established target, and we're writing 2 on it because we know we're 2 feet higher than we're supposed to be here. To a new established target, after sighting horizontal and measuring the theoretical dimension of 3.7 right here, you then need to deduct the 2-foot hike up from the dimension of 3.7 to arrive at 1.7. That is the vertical measurement of the grade line. That's where that guy is, right? So the above mentioned is the one to use for a fill situation, right? Because here is, I don't know, what do they call this? No, here's the proposed grade right here. This is your line of sight because you hiked up 2 feet. So after you have driven a left at the desired location, you would transfer the grade and deduct the 2 feet. So I'm trying to get this mark over on this stake exactly even with it so I can deal with things over here. So I measured up 2 feet, and once I sighted in on this, doesn't matter what I read, I just mark my stake where I am when my hand level is level, and I've got this right in the center bubble. I just marked a line right there, and that line I know is 2 foot higher, so I've got to bring it down. Now once I bring it down, this is my grade, right? So if I want to be right here and I measure from here to here, what goes on the stake? Fill 1.7. Got it? Started out 3.7, but we deducted the 2 foot, that leaves 1.7. So that's a hike up, and this is in a fill situation. It gets a little bit more difficult than a cut situation, but not much. Let's see what's next. Oh, there it is. This is a cut situation. Let's see what we know. Here, let's finish reading this. I like what they're saying here. For a cut situation, you should still transfer grade in whole feet, like we did up here. You should still transfer grade in whole feet like 3, 4, or 5 feet, but the hike up will frequently be some dimension other than whole feet. Look down here at figure 24. So in my mind, I'm just taking a look at this. The first thing I see is this is what I know, right? Right here. So what I need to do is figure out a way, this is in my way, to make a mark up here. Where do I put, I'm just go out of the blue. I want to be standing up. So I choose out of 3, 4, or 5, I choose a 4-foot boot. In other words, I want to put a mark on this stake that is exactly 4 feet above the proposed grade. But here's my problem. I can't see this grade. I can't even get my measuring stick down here. How in the world am I going to know where to put a mark that's exactly 4 feet above that proposed grade? The first thing I'm going to do is consider the boot I chose, 4 feet. Okay, so if I take 4 and if I subtract 2.4, that's going to give me an answer of 1.6. So if I go down here to where I can't see, and if I measure up 1.6 feet, draw me a line, put a 4 on it, and then I go to work. Doesn't matter to me anything else, because now if this cut calculation is right, and I have to believe it is, I may not put it on there, but if it's right, then this 4-foot boot is 4 feet above where I want to be. So 2.4 plus 1.6 is 4. Let me go over here and take this shot. Now look here, what if it read 4? What do you think we need to do now if it's reading 4? Nothing. If it's reading 4, we're on grade. But let's look over here. What is this? Let's say that I took a shot. Oh, let's see. I'll tell you what. Here's what we're going to do. Just like we did before. We're going to start cutting. And we're going to start cutting. Now then, if I took a shot here, what would I read? I would read these two things. I would read that right there, that hike up, because I came up 1.6 and I could measure this 1.9. So if I'm shooting from I'm pointing with my finger again, I can't believe it. If I'm shooting from when I say shoot, I mean looking at, from the existing grade, and I am reading what this guy that put this book together says, I am actually, in this case, if I'm on the ground and these two dimensions here are accurate, I'm reading, I think that's a 1.9, and I think that is a 1.6. 1.9 plus 1.6 equals 3.5. I'm reading 3.5. So if I'm reading 3.5 and I want to be reading 4, what do I need to do? If I'm reading 3.5 and not 4, that means I'm too high. How much higher is 3.5 than 4? Well, when you go down, your number increases. So I need this stick to read 4. So I got to take dirt away. As a matter of fact, I've got to take 5/10 of a foot away right here. Then when I put my ruler down here and I take a shot, I should be reading 4. That makes sense? So that tells me if I'm going to mark on this stake, if 5/10 of a foot will get me to 4 foot, then I need to put on that stake cut 5. And here we go again. We start taking out dirt. So I get down here, first shot, I read 3.5. That told me I need to come down 5/10. So I cut, say I read, let's say I read 3.8. Well, see, now we're getting somewhere. I'm still 2/10 too high. So I have to bring it down another 2/10 to get to where 4 is. Now that's the whole in a nutshell. That is how to use the hike up to determine where to put your boot. If I'd have chose a 3-foot boot, and with this cut, my boot would have been lower down here, and I'd still probably be away. That's why I chose a 4-foot boot, just by looking at the situation. I didn't have to take it, but I wanted to be standing up, so I needed a 4-foot boot. Now, a 5-foot boot would have probably been too high. I may not have been able to read that, from the existing ground. It might have been too high. So, I'm just feeling like we need to have a synchronous Big Blue Button. So I'm going to send out an announcement. I'm going to set a date. And if we have these things, you need to do everything you can do to be there. Not there, but on your computer. So we'll see how it goes. And I'll send out the notice, and then you respond to it through the inbox, let's say, and say, I just can't do that. I'm having surgery. That'll be, I guess, a legitimate excuse. But, you know, life happens. I want to try to get us there if I can to go over this with as many folks at once. So finish reading this. I'm going to go to the next slide, or not slide, but this is talking about elevation, and this is I'm going to leave this up to you. I'm going to let you look at this, read this, and try to understand all of this going on here. Look at here. See, this guy here starts out with a 4-foot boot, and so he sees the cut, so he needs to hike up 1.6. Now, here's your assignment. You can do this within your brain. I'm not asking you to turn into everything. Consider this elevation, known elevation above sea level, right here, and see if you can tell me where. Well, it tells you. So we'll see if you can come up with the elevations they got. See, they found out what this elevation above sea level is just by knowing this elevation and going through all of this. They found out what this elevation right here is by knowing this and considering the cut gave them this. But see if you can see how they put all of this 1, 2, 3, 1, 2, 3, and 4, how they calculated that. And it gives you the, I want to use the word power, but this is a powerful but very, very simple tool. One of the most important mechanical things in the world, I would guess, would be a ball bearing. And that's the most simple thing of all the mechanical things. But without ball bearings, we would be up that creek. So read this over. I'm going to put a notice for our Big Blue Button meeting. I want everybody to come. That's my wish. And we'll try to go through these in more like at a discussion format, perhaps, and see what happens after that. But for now, talk to you soon. Let's make sure I don't have anything else. Hold on. Is there anything else? This is the tailgate. Now, by going here, it does remind me of something I want to do, because I want you to continue working on this week 2 module. So just give me a second and see if I can get out of this. I wanted to do this. I'm not good. Give me a minute, and I will get out of it. Here, I want to take a look at your assignment and see what it looks like. The grade boot and the hike up, the tailgate, you can figure that out. Week 2, your assignment is using the grade boot. Let me give you a hint or two. This is your assignment. Look at the picture. This is your engineer's room, reading 1 foot through 6 feet. This is your grade boot. This is your cut. Take a shot at that grade boot, and if you read 3, what kind of action needs to be taken? None, right? So look at this first question. You're looking, don't forget what grade boot you're looking at. When you're on grade, you should be reading 3. What if you're reading 3.4? Well, you're 4/10 off. But are you 4/10 too shallow? Do you need to cut, or are you 4/10 too low? You need to fill. Do you need to fill? We know you're 4/10 off, but is it a cut? Do you need to go down, or do you need to go up? Well, I'm going to tell you in this first one right now, if you're reading 3.4, you're 4/10 too low. So you need to fill 0.4. And that's all the help you're going to get from me. You can do it. If you just flat, get stumped, use the inbox, my phone number. That's written in different places. So give me a call. I will talk you through it, but I'm not going to do it for you. So if you've got that, then you'll get through this assignment fine. Now I'm going to shut down this video, and I'll be getting back to you, perhaps to try to get this Zoom or Big Blue Button deal done so that I can be sure that you made it this far. This is the basis for everything else in this course. What we've been through is the basis for everything else in this course. Okay, with that said, adios.